Welcome to 13 Cubed. In this episode, we're going to talk about PsExec. This is not a tutorial on how to use PsExec. Come on, this is a 13 Cubed episode. We're going to be talking about detection opportunities and forensic implications of a threat actor using this tool. But why PsExec? It's certainly not because it's some advanced, super secret tool that no one ever uses. It's quite the opposite. It's ubiquitous, it's everywhere, and it's simple and it's easy to use and it just works. And that's exactly why threat actors continue to use it. Remember, in most cases, a threat actor is only going to be as advanced as they need to be to complete their actions on objectives. So very often they'll use PsExec. And to further complicate things, many times customers already use PsExec extensively in their environment in lieu of more suitable tools like PowerShell remoting or something like that. And the noise of what the threat actor is doing just kind of blends in with everything else that's happening in the environment, making it even harder to detect. I know what you're thinking though. Some of the easy detection methodology is things like looking for event ID 7045 or service installations for PSEXESVC. And yes, of course, we're going to talk about that. But we'll also cover a couple of other things that you may not have considered with regards to detecting PsExec usage. And if you stick around towards the end, there's something really cool that's based on an about DFIR.com article relating to PsExec detection. And I'd love to show you kind of a spin on that article, something new that I found actually by accident that I haven't seen mentioned anywhere else before. So something pretty cool there. I'll show you when we get to it. Let's not get ahead of ourselves though. First, this episode is brought to you by me. If you're looking for affordable, online, on-demand, and get this, non-expiring Windows forensic training, look no further because the first official 13 Cube training course investigating Windows endpoints is here. Go to training.13cube.com and within a couple of minutes, you can start your forensic journey. This is not just for people new to forensics. If you already work in the field and are looking to ramp up your skills to that next level, this training will be perfect for you as well. There is hands-on practice, and there's also a practical and test component where you can earn a certification and digital badge, and you get all of this for a one-time fee. And again, it does not expire, and the course will be updated over time to make sure that it remains relevant and always up to date with the latest and greatest Windows forensic artifacts. So again, go to training.13cubed.com today to get started. With that out of the way, let's switch over to a command prompt and take a look at using PsExec against both a Windows Server 2022 box and a Windows 10 box so that we can generate some data for us to actually go look at. Starting with the Windows Server 2022 box, I'm going to run PsExec//win2022-test-vm, which is the name of that system, -u, and I'm going to use the username of administrator. I'll use -i for interactive, and let's just run ipconfig for the first command. Something pretty simple. So there we go. There's ipconfig. Let's also run netuser for the second one. And this will, of course, enumerate the local users on the system. There we go. And then lastly, let's just run net local group to enumerate the groups. Again, it doesn't really matter the commands that we're running. We're just doing this to generate some noise on the target system so that we can take a look at the artifacts that will show us that PsExec was indeed used against this particular system. And there's the output of that command. Now, the last thing I want to do before we hop over to an RDP session to that machine is actually specify an alternative option here with PsExec. If I run this without any options, you will notice that there is a -a, -c, -d. There's many different options here, but specifically we're looking at -r. So -r will allow you to specify the name of the remote service to create or interact with. And that's exactly what we're going to do here. So let's clear the screen, repeat the last command that we had used, and actually let's just tack on -r and we'll call it win update. So that in theory should go ahead and create the service name of win update with a binary name of winupdate.exe instead of the default PSEXESVC.EXE. And if you're not familiar with what I'm talking about, don't worry, because when we take a look at the event logs on the system, this should all make sense. So let's give this just a second to finish. And there we go. Now let's hop over to that RDP session to this Windows Server 2022 box and take a look at what we have. Let's start by loading up the Windows Event Viewer. So I'll just start typing in event right here, and then we'll click on Event Viewer. And of course, we're going to drill down under Windows Logs under System. And you guessed it, we're going to filter the system log or channel for event ID 7045, which should show us new service installations. If you're not familiar with how PSEXEC works, every time you run PSEXEC against a target system, a new service will be installed. By default, that service name is PSEXESVC, and the resultant binary is also PSEXESVC.EXE. The binary is created in the root of the admin $share, which it is necessary to actually have that share available for PSEXEC to work. So what's going to end up happening is admin is typically C:/Windows, the root of the Windows operating system directory. And in that location, a PSEXESVC.EXE binary will be created alongside that service every single time you run PSEXEC. So in other words, if you run PSEXEC against a target system 5 times, guess what? You'll have 5 services, and 5 different times you'll have the creation of that PSEXESVC.EXE binary, because every single time it finishes, it actually deletes that binary from disk. So therefore, if you run it 5 times, you'll actually have the creation and subsequent deletion of that binary 5 different times. That has a very interesting implication for Shimcache or app compat cache that we'll talk about in a moment, but let's not get ahead of ourselves. First off, at the very top, you'll notice the very newest event ID 7045, and you can see that it says a service was installed in the system. And sure enough, this service name is WinUpdate, not the default of PSEXESVC. And you can see that it's pointing to the bin path of %system root %, which of course is typically C:/Windows, and then WinUpdate.exe. If we go down one from there, you will notice PSEXESVC, the default service name, along with that default binary name of PSEXESVC.EXE. And then before that, there's another PSEXESVC, and before that, another PSEXESVC. So these 4 7045 events correspond to what we just did. Makes sense, right? So let's recap. Every single time PSEXEC is run against the target system, there should be a resultant event ID 7045 within the system log or system channel that tracks that service installation. And remember, a binary is written to disk every single time that happens as well. The binary is subsequently deleted upon completion of that command. So let me show you that as well. If I bring up a command prompt here with just CMD, let's zoom in and go into Windows, and I'll show you that WinUpdate.exe does not exist, nor does PSEXESVC.exe. Now, if we parsed the USN journal, we should be able to find historical evidence of those files being created and subsequently deleted. So that's a key factor and something else you could look for to show previous existence of PSEXEC if you didn't have access to the system log, or if the system log had been cleared, which is very commonly done as an anti-forensics method. So keep that in mind as well. But now I want to revisit what I said a few minutes ago with regards to Shimcache and app compat cache. What happens to Shimcache and app compat cache that could help us potentially track the usage of PSEXEC? Well, I'm glad you asked. Let's go ahead and switch back over to a command prompt. So back on our source system, let's run PSEXEC again. This time I'm going to choose a different box, a Windows 10 system. So I'll do //win10-test-vm. The username here is going to be DavisRG, and I'll just run cmd.exe in this case to get an interactive command prompt. I'll go ahead and type in the credentials here, and at this point we have a command prompt. I can type hostname, and you can see that we're on the system, and we can see that I am currently the DavisRG user as expected. I'll type exit to end that session, and there we go. We have just completed our PSEXEC session to the Win10 test VM. Now let's go ahead and switch over to an RDP session for that system and take a look at a couple of things. We'll first start out by looking at the event logs just like we did here. There should be obviously an event ID 7045, but then we can talk about Shimcache. And here we are on that Windows 10 system. let's go ahead and load up Windows Event Viewer, just like we did on the Server 2022 box. And of course, we're going to go to Windows Logs, then System. We'll go over to the right and choose Filter Current Log once this loads. And then we'll be choosing 7045, just like before. So I'll type in 7045 and click OK. And at the very top, as expected, we have a service installation for PSEXESVC, which is the default service name, along with PSEXESVC.EXE, the default service binary. And just as before, that binary will not be present on disk. So if we go here, I'll zoom in for you, and we type in DIR PSEXESVC.EXE, you will notice that it is not here because it gets cleaned up after that execution. Okay, so far so good. So we know how PSEXEC works, but now with regards to Shimcache, what must happen for Shimcache to be flushed to disk? Well, the system has to be shut down or rebooted, correct? Otherwise, that Shimcache data will not be flushed to disk, or specifically to the system registry hive. So let's go ahead and reboot this Windows 10 system, come back and then parse the Shimcache, because I want to show you something that's kind of interesting here. Okay, we're back on this Windows 10 system after a reboot, so Shimcache should now be flushed to disk. Let's go ahead and load up a command prompt here and take a look at parsing it. We'll go into Tools, Zimmerman, Net6, and what we're going to do is simply run app-compat-cache-parser.exe. As a reminder, if you run it without any options, to take a look at the available options, you can leave off the -f. In other words, don't specify the full path of the system hive. If this option is not specified, the live registry will be used, and that's exactly what I want to do at this point. So let's go ahead and run this with just the --csv option, pointing to users, Davis RG desktop, and then for the file name, this is optional, but I'll just call it shimcache.csv. Okay, so let's let that parse, and as you can see, it's already done. Let's minimize this and go over to the desktop and open the resultant CSV file that was just written. And what I want to show you is, of course, any Shimcache entries that are present for PSEXESVC. You see where I'm going with this. So let's go up to the top right and we'll type in PSEXESVC and filter, and notice that we do indeed have one Shimcache entry. The modification timestamp right here is 2023-04-13 at 15:38:46 UTC, and you can see the full path. So what does this mean? First off, in Windows 7, what's interesting is that every time you run PsExec against a Windows 7 system, you're going to end up getting a Shimcache entry for PSEXESVC, or whatever you name the service if you change it from the default name. And the reason for that is because every single time you run PsExec, as I mentioned, a brand new binary for that service is created and dropped in admin $, which of course is C:/Windows typically. And upon doing that, when a new file is created, it is added to the Shimcache. Now, what happens to the MACB timestamps when a new file is created? Well, the MACB timestamps are all set to the time the file was created, right? Which means in the rare circumstance of PsExec, the actual M timestamp tracked by Shimcache can be used in this manner to show when PsExec was actually executed against the system. How cool is that? So in other words, if you're looking at a Windows 7 system, you might have 10 different PSEXESVC entries in the Shimcache, and every single timestamp you see there should correspond to the creation time. Why the creation time? Because remember, the M, A, C, and B timestamps are all going to be set to the time the file was created, and every time you run PsExec, a new file is dropped. So therefore, you'll have an entire history of all the times PsExec was run against the system. On Windows 10 and Windows 11 systems, you'll note that we have a single Shimcache entry, which in this case should correspond to the last time PsExec was executed against the system. So in other words, at 2023-04-13, 15:38:46, that should correspond to the last time PsExec was executed against the system. Let's check that. We'll go ahead and load up the Windows Event Viewer, and we'll go back to where we were under Windows Logs. We're going to go into System, and we're once again going to filter the current log on 7045. And what we're going to do is simply match up that timestamp and see if it makes any sense. So right here under all event IDs, I'll just type in 7045. And if you take a look at it, it's 11:38:46. And what was that Shimcache timestamp again? 15:38:46. The difference being that you're looking at UTC time here, whereas in the event viewer, it is local time. But notice the timestamp matches exactly. So what can we glean from this? Well, we can say that the last time PsExec was run against the system was this timestamp, the actual M timestamp for this particular binary. How cool is that? Makes sense, right? All right, so there is one last thing I want to show you with regards to PsExec, and it all goes back to that aboutdfir.com article I mentioned in the introduction. In early 2023, an article entitled "The Key to Identify PsExec" was published on aboutdfir.com. It was written by Fabian Mendoza, and it was of immediate interest to me because it provided yet another method for detecting PsExec. The TLDR is that starting with PsExec version 2.30, which was released in early 2021, anytime a PsExec command was executed against the target system, a .key file, a KEY file, would get written to the target system within the root of the Windows directory. The file would have a naming convention of PsExec-source hostname. Yes, you heard that right. The actual source host name of the system from which the PsExec connection originated, then another dash, and then 8 unique characters followed by the .key extension. And again, this will be created, but then subsequently deleted, and that would happen in the root of the Windows directory, typically C:/Windows. So using the USN journal, you could look for those file creation and subsequent file deletion events and actually have yet another method of detection for PsExec on a target system. But not only that, you could see just based on the naming convention itself, the actual host name of the system from which the connection originated. So that's pretty awesome. But to take this one step further, let's think about Prefetch, which Prefetch in and of itself is yet another method of detection. Now, to be clear, I'm not talking about Prefetch for PsExec. Of course, that will exist on the source system. On the target system, there will also be Prefetch, assuming you're looking at a Windows desktop operating system, not Windows Server. And that will be a prefetch file for PSEXESVC.EXE, or whatever you've named it, right? It doesn't necessarily have to follow that naming convention, though in most cases I see that it's generally left at its default name. Let's go ahead and switch over to the RDP session for the Windows 10 box that we were just on and take a look at a couple of things. So as you can see, I'm in the Windows Prefetch directory, and if I just do a dir PsExec, you will notice that we have the client itself, because I've actually issued PsExec from the system. But if I hit tab, notice this file is the one we're after. This is the prefetch file for PSEXESVC.EXE, which would be found on the recipient end of a PsExec connection. And there it is. Of course, the timestamp being displayed to us by DIR is the last modification time, and this should map back approximately to the last time the system was the recipient of a PsExec connection. I say approximately because don't forget, you have to subtract somewhere between 0 and 10 seconds for the prefetch delta. If you don't know what I'm talking about, take a look at the prefetch video that will be linked in the description and in the top right corner. Okay, if I do a dir/tc just to show you, we can also look at the creation time, and this should map back to the first time the system was the recipient of a PsExec connection, minus again that 0 to 10 second delta. So this should be pretty straightforward and kind of self-explanatory to you, and just another method of detection. Now you're probably thinking, well, wait a minute, why don't you just parse the prefetch file and then get even more information? And in doing so, we should be able to determine the total number of times this binary executed and the last 8 of those specific timestamps. Let's go ahead and switch over to Tools, Zimmerman, and then Net6. And what I'm going to do is run PECMD.exe against the Windows Prefetch PSEXESVC.EXE prefetch file. So when I do this and scroll back up to the top, you will see that we indeed have all of the expected information, including our run count, which is listed as 3, the last runtime listed right here, and then the previous 2 runtimes right here. Among all of this information, though, don't forget that we do have directories and files referenced, and here is where it gets interesting. you might already see where I'm going with this. Under Files Referenced, if we scroll down, let's take a look at what we see. Do you notice anything interesting here? Maybe you're looking at it right now. I'll highlight it for you. Check this out. Remember the .key files that we were talking about from the about.dfir.com article? Well, there it is, referenced in the prefetch for PSEXESVC.EXE. And, of course, this DFIR box is indeed the host name of the source system, the system from which the PSEXEC connection originated. How cool is that? So we can not only leverage the existence of those key files within the USN journal, but also within Prefetch. Yet another detection method that we have, and another ability that we have to be able to see the actual host name of the source system from which the PSEXEC connection originated. In fact, just to make this a little bit more clean, I'll just go ahead and pipe this through find string, and we'll search for .key. And when I do this, you should get a nice clean output. And check it out. Notice that we also have another system listed here. That's actually this very system, because I actually ran PSEXEC on this system to elevate to the system user, which you can do with the -s flag. And so, yeah, the actual system itself has the PSEXESVC.EXE service installed on it, even when you run it against itself. And by that nature, there should be no surprise there that there's going to be a .key file present as well with the host name of itself, win10-test-vm. So that is pretty awesome. So let's recap the detection methods that we've covered in this episode. We've got good old system event ID 7045 in the system event log or system channel. We've got Shimcache for PSEXESVC.EXE on the target system, Prefetch for PSEXESVC.EXE on the target system, including potential references to the .key files therein, showing the source system from which the PSEXEC connection originated. We've got PSEXESVC.EXE via the USN journal. And then lastly, PSEXEC-source hostname -8 unique characters .key within the USN journal. So all of those detection methods could be used to profile potential PSEXEC activity on the target system. That's pretty awesome. And I'm not saying that that is a comprehensive list by any means. There are certainly going to be other methods that one could potentially use, but those are the ones that we have covered within this episode, and I hope you found this information useful. Anything I've shown or referenced will be linked in this video's description, so I encourage you to check that out. And as always, thanks for watching, thanks for subscribing, and I'll catch you in the next 13 Cubed episode.